All right, so rainbow check and factoring fixes are two different topics, and I'm going to show you where those fit into the factoring that we've been doing. So Roman numeral 1, we're going to start with rainbow check. And here's an example. So 8x squared minus 14x minus 15. This is what we've been working on since last week. And you're supposed to factor it. Okay, so when you factor this, the factors that work for 8 are 2x and 4x. And then during the factoring process, you have to figure out where the factors of C go. So it's kind of a guess with what we've learned so far. So let's say we put a +3 and a -5. In the process of factoring, you then multiply back together again to see if the 3 and the -5 are in the right place. And that's how we know. So we've been doing this at 2x times 4x. And when you multiply, you distribute the 2x, and then you distribute the 3, and columns work really well. So 2x times 4x is 8x squared. And then 2x times -5 is -10x. Then we drop down and move to the 3. 3 times 4 is 12x. 3 times -5 is -15. And then we add it up. So we get 8x squared plus 2x minus 15. And the signal that you're ready to switch the C's is if the middle number looks like the B value, which it doesn't. It's a 2x, and we need our B value to be a -14x. So the answer is we switch the C's. So draw 2 pairs of parentheses again, and we have a 2x and a 4x, and we just changed the C's. So we put the -5 first and the +3 second, and then we remultiply. So 2x times 4x is 8x squared. 2x times 3 is 6x. Drop down. We're now on to the -5. -5 times 4x is -20x. -5 times 3 is -15. And we add it up. We get 8x squared minus 14x minus 15. And when we switched the C's, we did get the -14 that we wanted, which means our factors are correct. All right, so that's the process that we have been doing on the homework. So this is the old process. So now I'm going to show you with the new process how you can get away with a lot less work. So let's write down our original two factors, 2x plus 3 and 4x minus 5. Okay, so to explain the new process, you have to look at the old process. The difference between wrong C's and right C's was the middle number. So our focus is here. Because the 8 and the -15 were right both times. It's the middle that we weren't right on. So on this one also, we just looked at the middle. So wouldn't it be great if all we had to do was just do the middle instead of remultiplying everything and getting the 8 and the 15 both times? Just do the center. And this is where rainbow check comes in. It's basically just doing the middle, so it'll save you some work. So why is it called rainbow check? Because when you do this process, you multiply 3 times 4x and 2x times -5. And you can see that makes a little rainbow. So inside 2, 3x times 4x is 12x. Outside 2, 2x times -5 is -10x. Add it up and we get 2x. And this is exactly what we did when we multiplied the whole thing out. That middle and this middle are the same. So the result is the same. The 2x is not the negative 14x that we want. So we switch the C's. And that gives us 2x minus 5 times 4x plus 3. And now we do rainbow check again, inside 2 and outside 2. And that gives us negative 20x plus 6x, which is negative 14x. And that negative 14x is what we wanted because that was in the original. So we know that the C's are correct. So rainbow check lets you check for C's. Actually, you can usually do it in your head, which is really nice. You can always completely remultiply whenever you want, but it's just more work. That's all. Okay, so for rainbow check, the biggest positive is that rainbow check is shorter than multiplication. So it's a faster process than remultiplying. Another big plus is rainbow check checks the C terms to see if you've got them in the right places. The biggest minus for rainbow check is it doesn't check the rest of the answer. It doesn't check the rest of the answer. So your C's could be in the perfect spot, but if the other numbers aren't correct, rainbow check won't show that to you. It will only check the placement of the C's. Luckily, most of the time we pick the right factors for the A term and the C term. It's just a matter of getting them in the right spot. Okay, so that is rainbow check. I'm going to go to my next page here, Roman numeral 2. Okay, what we're going to do is we're going to use the rainbow check to place the C's correctly the first time. So that's got to hold some interest for you. So we're going to use rainbow check to place the C's correctly the very first time. So this will actually eliminate the need to check it all, which is nice. Okay, so let's give the example. 5x squared minus 17x plus 6. And I'm going to shortcut this a little bit. So your A term is 5. So you're going to use 1 times 5 for the A. Your C term is 6. So you end up using negative 2 times negative 3. Negative 17 is your B. Okay, so you tried out a bunch of factors. You found the winners. And then you tested it. 1 times negative 2 plus 5 times negative 3. So that was firsts and seconds. And that gives you negative 2 minus 15, which is negative 17. And you said, yay, we got it. And check that off. You draw your 2 parentheses. You split the A's, so 1 and 5, and then split the X's, X and X. Now, here's where we've been guessing what we're going to do. Like, we don't know which way the C's go. So this is where you're going to look at your checking step and notice what's being multiplied together. We're multiplying the 1 and the negative 2, and we're multiplying the 5 and the negative 3. Thank you. Yes, he's here. So how is this going to help us? Well, remember in rainbow check, you're going to multiply the 5 times that number, and you're going to multiply the 1x times that number. That's your rainbow check. So I want the 1 to be multiplied by the negative 2. 1x is on the outside, so I'm going to put the negative 2 on the outside. In the middle, 5 is being multiplied by -3, so I'm going to put the -3 on the inside with the 5. So I'm using rainbow check to put them where I want them, and I'm basing that on how I multiplied them to get the -17. That's what's telling me 1 goes with -2, 5 goes with -3. So then let's verify with actually rainbow check. So inside 2 is -15x. Outside 2 is -2x. We add it up and we get -17x, which is what we wanted. Now, if this is like totally confusing for you, you don't have to do it. You can just put the A's in, guess on the C's, multiply it together, and if it doesn't work, switch the C's. If it does work, leave it, and you're done. That will always work. I'm just offering you some shortcuts that you can choose to use to make your life a little bit easier. That's the goal. All right, Roman numeral 3. Factoring fixes. Factoring fixes. Okay. So let's do an example. Let's say you've got 2x squared plus 4x minus 16. Now, what you're supposed to do is if you can divide a number out, you need to do it. And they're all even numbers, so you would divide a 2 out, and then you would factor it. This one ends up being x plus 4 times x minus 2. So your job is to factor out the monomial. Monomial means single term. First, before you start factoring, you're supposed to take that 2 out. But what happens if you don't take the 2 out? Okay, so here's what happens. If you don't take the 2 out, your factoring will look one of 2 ways. It will either be 2x plus 8 times x minus 2, or it will be x plus 4 times 2x minus 4. And if you look at the original one, it's close. Like on this one, it's got the x minus 2, but this factor is different. In this example, it has the x plus 4, but this factor is different. What happens to the 2 is it reappears inside one of your 2 factors. Can you see how both of these are even numbers? That's where the 2 went. It's buried in here. So to fix that, you can divide the 2 out of one of your factors, put the 2 in front, and then when you divide out 2, you're left with x plus 4. Of course, the x minus 2 didn't change, but now you have the correct factorization. You've fixed it. Same thing with this second one. The 2 has reappeared in the second pair. So divide them by 2, put it in the front, and you're left with x plus 4 times x minus 2. Again, now it is correctly factored. So that's how you fix it if you forgot to divide something out. So what is the rule? The rule is if you can factor a monomial out, if you can factor a monomial out of either binomial, you must do it. If you can factor a monomial out of either binomial, you must do it. And this goes for numbers, x's, y's, anything you want to divide out.
Is there a reason we factor out the 4 in the first?
Yeah. No, because that doesn't have a 4 in front of it. If it was a 4x plus a 4, you could take it out.
Oh.
Yeah, it's got to come out of the same binomial. That's the tricky part.
You divide stuff out of